Hello, everyone, and welcome to the latest episode of Expert Insights Live. Today, we've got Jian with us. Jian, would you like to introduce who you are and what?
Absolutely. And thanks a lot again for inviting me today. Yes, I'm Gianmarco Iodice. I'm the author of the TinyML cookbook and also tech lead at ARM for the ARM Compute Library. I look after the Edge AI, so AI deployment on edge devices from microcontrollers to mobile phones. Although I also look at the ML deployment in the servers nowadays. My experience is mainly about optimizing these crucial models for running on constrained devices where you have a limited power budget or reduce computation capabilities in order to run it very, very efficiently. This is my background, more or less.
Perfect. Thank you, Jian. So, everyone who's joined us, if you all can just drop in a message saying hi and where you've joined from, it will help us understand that it's not just Jian and I talking to each other, and there are more people with us. Also, if you have any query, feel free to drop them in the comment section. The last thing, there is a tracker going on at the bottom over here. As you can see, we will be giving away two ebooks to a couple of lucky winners who will be drawn live during the raffle. To enter the raffle, just comment hashtag packed as the ticker says right here. Just comment that, and yeah, I'll do a raffle a couple of times during the session. So, Jian, while we're waiting for others to join in
Absolutely.
and we're waiting for their messages, uh, let's start with a few queries that I have. Uh, First and most important, I think we covered what is TinyML last time. So I'll begin this time with who are the people who are actually inclined to be working on TinyML?
Okay, interesting question. So, in particular, developers with an interest to make ML ubiquitous. What does it mean? It means that when you want to bring intelligence on top of recent sensors around the world, and we don't know that basically there are so many devices like this. How many devices do we have with sensor capabilities nowadays? Well, probably billions around the world. Well, TinyML is exactly the ingredient to make smarter and to give a meaning to the data we acquire through these billions of devices around us. It could be, for instance, to make our car parking smarter. It could be also to predict fault in industrial manufactories, or it could be something more sophisticated. For instance, it could be in our smart speaker to recognize the famous word, or okay, Google, or to unlock the interaction with the device. So there are absolutely endless opportunities, but this is not just a word. Well, there are endless opportunities like any other technologies. No, there are endless, because also um, the budget, the money budget, in sometimes can be very, very little to unlock big challenges. And that is probably what it makes very, very attractive, this field, because you don't need a huge amount of budget to have an application with an impact, but actually with a limited budget, you can unlock big use cases. That is certainly what makes different TinyML from many other fields.
Perfect. And we can see that there are a lot of people who started joining us.
Yeah.
I can see there's a comment on YouTube, Vinay Banca. Then there is Marcelo from Brazil. Hello, Marcelo.
Hey.
We've got Yichen from Arizona. She's curious about this topic. We've got Nicholas from Greece. Hi, Nicholas. Then we've got Doug from Brazil, and he's in California. Hi, Doug. Got a lot of people joining in. Thank you for dropping your notes in. Hello, Mark. He's joining us from France. There's Ramon from Florida. And there is another one from YouTube called Funso. Hello. Thank you, everyone, for dropping in your notes. As I said earlier, there is a ticker going on at the bottom to enter the raffle if you would like to win an ebook of GN's latest TinyML cookbook, second edition. Please
Please.
comment. Yep, that's the one, the book that's holding there. If you want a ebook of that, please enter hashtag packed in the comments. And also, if you have any queries, please feel free to add them into the comment section and I'll pop them up. Funso says that they're also joining us from France. Welcome to the session. Uh, so moving on with the queries, Jian, while I'm waiting for others to ask theirs. So how would a beginner start their journey with TinyML?
Okay, so how do you start your journey with TinyML?
Mhm.
Well, here certainly you don't need a huge machine to unlock a smart application. Here you probably just need a budget of, I don't know, 20 euros, 20 pounds, $20 more or less, to have a microcontroller to
Mhm.
start experimenting and see actually the ideas coming to life. That is actually the things I like. When they ask me why should I care about NML, the first thing I always say is, well, because it's cool. It's absolutely cool. Of course, it's not enough saying cool because there are many other reasons. But one of the cool thing is, well, you buy these tiny devices, these microcontrollers, which are very capable, and with only 20 pounds, you can see your ideas coming to life. It's absolutely great. For this second edition, I also managed to continue a project I started a long time ago. It was more than 10 years ago. It was my very first experience with microcontrollers, and I wanted to learn, for instance, how to use the PWM to generate signals with the microcontrollers. What I decided was, okay, let me build actually an audio player. So I built this audio player. I was super happy because I learned so many things like using the PWM, using the touch screen. And at the end, I wanted to add an auto equalization of the audio based on the genre of the music. So instead of basically so telling what genres I was reproducing, basically write an algorithm to predict to learn what music was playing and actually auto.
Mhm.
But 10 years ago, although ML, I mean, was absolutely there, but was not simple enough. I mean, it's not like today where we have also different frameworks, very easy to use. Um, so it was quite complex, and I had to abandon the idea. I need to be very honest. But for this second edition, I said, okay, let me take what I left and let me see if I can build it. Um, and well, there are so many different frameworks, very easy to use, that I had really the pleasure to see these idea come to life and be able to recognize the music genre, for instance, to auto equalize the music. This is just to give you some ideas and a bit of contents of what you can find in the book.
Perfect. I can see that Marcelo has mentioned that he's liking the book already. Marcelo, if you can just add in the comments, what do you like about this book? That would be helpful, not only to us, but also the rest of the audience. Thank you for taking the time. And I can see a lot of people have already started entering the raffle. There are about 4 people who've entered the raffle. If you haven't, please comment hashtag packed. Uh, so there aren't any questions, so I'll continue asking mine, and I'm really glad that I can do that. Uh, so let's talk a little bit about the current trends because generative AI is moving so fast. Uh, how do you think generative AI and TinyML link up together?
Uh, how many hours do I have? Probably just this, right? So we cannot have more than half an hour to talk about it. But that is, I like this question. Um, and what can I say? So first of all, although in the bio I said I'm working on Edge AI, when I said Edge AI, I also included generative AI.
Mm.
Well, I can tell you this. TinyML and generative AI are not disconnected. Now, what it means, this statement, it doesn't mean that the use cases we are seeing now with generative AI are applicable to microcontrollers. I'm not saying absolutely this, but I'm saying another thing. I'm saying that if we address TinyML to make these models smaller, we also solve the problem of generative AI at the edge. Because what it makes different, the difference between TinyML and generative AI is just the scale. You
Mm.
have exactly the same problem. On one side of the spectrum, on the TinyML field, on the TinyML space, you have machine learning models that can be probably up to a megabyte of weights that must fit in let's say in a few kilobytes of RAM and maybe a couple of megabytes of flash. On the other side of the spectrum, you have gigantic models that anyway need to fit in a limited memory that you have on board. So as you can see, basically you have exactly the same problem. The scale is just different, but the techniques you apply for TinyML to run these tiny models in the TinyML space are also applicable for generative AI. And that is what I'm saying is these two fields are not disconnected because all the brilliant idea that we have for TinyML would certainly help generative AI to run faster
Mm.
and efficiently and unlock generative AI at the edge. The use cases, well, generating images or generating text probably are not, or at least I cannot see it relevant for the microcontroller space because here we work primarily with sensors. So
Mm.
here we want to give a meaning to sensors. But there is a field of generative AI that could potentially land in the TinyML space, that is the prediction. So using generative AI to predict or forecast a data in time. That could be an interesting area. But from what I can see, we are still far away from the model size target that we need for TinyML. But TinyML will certainly help generative AI, and is already helping.
Perfect, because TinyML helps gather a lot of data through its sensors, and that is actually inputting data for generative AI.
Well, I can probably give an example because I
Yeah.
told you actually that is helping, but how is helping? Well, even if you have, as I said, you have these probably 1 megabyte of model is already quite big, but one of the data type that finds applicability in the TinyML space is int4, int8.
Mhm.
And guess what? These are very crucial also for generative AI. So all the techniques that are used for deploying these models on microcontrollers are also extremely beneficial for generative AI. That is what I'm trying to say.
Perfect. I can see that we've got a wide, diverse people in the audience. We've got Mohammed, who's joined us from Pakistan. We've got Jawad, who've joined us from Morocco. We've
Nice.
got someone who's joined us from South Korea. I'm sorry, I can't read Korean to read your username. And Marcelo has responded, he's read your first edition and saying that it went on not only to cover different development boards and MCUs, but also over different frameworks to work with TinyML. Marcelo, you should check out the second edition of the book. It does quite a lot more. Uh, Speaking of Jian, so how is second edition different from the first edition, or what's new in the second edition?
Okay, so this second edition is an incremental version of the first edition, as Marcelo said. So the first edition already covered different frameworks and two microcontroller boards, in particular the Arduino Nano 33BLE Sense and the Raspberry Pi Pico. Um, and this second edition is an incremental version, which means that you can find more projects in addition to what you had for the first edition. Plus, you can find an additional board to practice the principles, because this is a very practical book, but oriented to the principles. So personally, when I wrote the book, I didn't want to write just a list of instructions to deploy in the
Mm.
machine models. I wanted to, well, provide instructions, but with always the why in our head. Why we are doing this? Why we are doing that? Therefore, at the end of each project, you can practice the recipe on an additional one to see if you have, I mean, if you understood the principles, and turn to life the same project on a different platform. So the other thing is about the frameworks, because during the first edition, well, TinyML was evolving so fast that also the frameworks were not, let's say, were ready but not stabilized. So in this second edition, instead, the frameworks are definitely much more stable, and all the projects are aligned to the latest version of all the tools, like TensorFlow Live for microcontrollers, Edge Impulse. So that is also the other addition. For instance, one topic that was quite in different forums of different microcontrollers vendors was, how can I have a latest TensorFlow Live for microcontrollers Arduino library? So the book this time, instead of using a pre-built one, well, there is a pre-built one, will also explain how to build your TensorFlow Live for microcontroller library, so you can update the library and create even more smarter applications. So it's a more, I mean, it's more. It's more compared to the first edition.
Perfect. So Jim, we've started getting queries, and there are people on YouTube who've asked their queries. The first one is from Vinay, and he asks that how is TinyML useful for automation ML?
Automation, what do we mean with automation ML in this context? So I guess not the discovery of the ML models, right? So if you can tell me more about what you mean about automation, I can certainly answer this question.
Yeah, we can come back to this. So, Vinay, if you can just add more context around what do you mean by automation ML, and then we'll come back to your query. So we've got Mohammed from UAE, and he inquires, can I use my segmentation model on TinyML?
Okay, difficult to say because I don't know what segmentation model you're using, but what I can tell you is segmentation is absolutely an interesting use case also for TinyML, because in some scenarios you want to detect the area of your objects. For instance, in an industrial, in a manufacturer, could be quite critical to have a camera on a belt, and on the belt you have the different items that you want to segment to check the quality of these items. So segmentation is absolutely another interesting use case for TinyML, along with object detection. For instance, in the second edition of TinyML Cookbook, there is a new project for using for detecting objects using the formal algorithm of Edge Impulse. Well, object detection as the segmentation is quite complex task to accelerate, because here you don't just classify an image. In a segmentation, you classify each pixel. With object detection, you classify a region. So there is more to do. And of course, the more means more power and more computational cost at the same time. But object detection can be addressed in TinyML with this algorithm with FOMO, which is very interesting. Because why I like this algorithm? Because it helps you to because they deploy this object detection, not just taking a model that works well on the server and deploy straight away on these devices. They also change the approach to solve object detection. And that what makes TinyML the key for a machine learning. Not just taking, oh, I have this model, let me try on microcontroller. Because if you use a pre-trained model, most of the time it won't work. You have to think, you need to be innovative at the same time. You need to think different in a different way to deploy such a big models on these devices.
Perfect. The next query we have is from Jawad, from the one who was from Morocco. Is TinyML just available in Python, C, and C++, or is C# support possible?
Okay, so in the microcontroller space, we primarily use C and C++. There is also MicroPython that you can use. These are the three languages that are very, very, that widely used in the microcontroller space. These are the languages that you should know also for as a prerequisite for the book. You don't need to be expert in these three languages, but a basic understanding of C, C++, and Python. That's it.
Then we've got a question again on YouTube. Can you suggest best microcontroller? I think ESP32 is the cheapest and feature loaded if we compare it with RPI MCU. Can you suggest the best hardware we can start with for TinyML? So I think a budget and best thing is what they're looking for. Good value for money.
Okay, that is an interesting question. So best microcontroller is absolutely difficult to say, because there are different microcontrollers which differ for cost and different for hardware capabilities. That is the reason the book provides three different platforms that are different for features and also cost. For instance, you have the Arduino Nano with a lot of sensors on board. You can plug it to your computer. It works, out of the box. We don't need to deal with installing drivers, which is quite important if you need to build sophisticated TinyML applications. On the other hand, you have the Raspberry Pi Pico, where it's very, very cheap, but you don't have all the sensors on board as the Arduino Nano. That is the reason the book also explains how to connect the sensors to the Raspberry Pi Pico. So I try to balance these two boards because they can present two development scenarios. This development scenario where you have everything, and the development scenario where you don't have everything, but you can still do great things. Well, best, it depends on what you have, your budget, because your budget could be not just $10, let's say. Your budget could be also $1. And I can give you a very simple example with the end of the book. So I'm gonna spoil the end of the book today. So if you haven't bought it, be prepared. But the conclusion of the book is about a project that I have done with the University of Cambridge and ARM to deploy ML, machine learning, on a microcontroller powered by algae. Well, you probably heard correctly. So the algae you can find in the river or in the sea. So that was absolutely a very cool project. A very cool project. I like challenges project. That was quite challenging, but because at the same time it demonstrated the full potential of TinyML. For this project, we had a very limited power budget, because the algae are very cool, because they can, in this scenario, we have replaced the battery with algae. They work like a solar panel, so you don't need to attach anything. but with a difference that can generate energy also during the night. Even if in absence of light, they can generate energy. But what was the limiting factor? The power budget. Well, that was one of the reason the best microcontroller in that case was actually a microcontroller that costed just 70 cents, probably less, because it had a very, very little power consumption that was capable to run this sophisticated machine learning algorithm.
So, Gian, if you were to recommend a good value for money microcontroller uh, for a beginner, which one would that be?
Well, this one is absolutely good. I think uh, the um, the Arduino, Raspberry Pi, and SparkFun, they provide a very good selection of microcontrollers. You need also to consider the programmability experience at the same time. So it
Hmm.
depends what platform you have used in the past. I give you an example. If I'm developing on the Arduino an application and I want to migrate that application on a different platform, I don't want to rewrite the application every time I change the platform. I want performance and code portability. And that is the reason I'm saying, well, I very like the Arduino, Raspberry Pi, and SparkFun because, well, although they're different because of in terms of features and cost, you can find a wide selection of different capabilities, but the code remains the same. So I can experiment on one, I can bring the code on the other one, and will work for sure. That is the reason. I think these three are quite good, but there are also many others that are absolutely valuable.
Perfect. Marcello, in fact, in the comments has suggested that the Xiao ESP 32S3 Sense is a cheap and powerful device for TinyML. Probably if NF66 wants to check that out, they can. Um, Vinay has responded to his earlier query that automation ML for cars. How is TinyML useful for automation cars?
So, okay, so automation ML for cars, how TinyML is useful for. So are we referring to? I guess we are referring to TinyML in the automotive space, probably.
Hmm.
So, well, I can say that plenty of things in the automotive space for TinyML, but this for a long time. Uh, I mean, we have smart cars, and most of the smart things are because the cars now are equipped by a lot of sensors on boards that can, for instance, I don't know, unlock the boot when I approach the car, or for instance, inside the car, they can have smart cameras to detect if there is a child on board, and maybe have an alarm to notify um, I mean, the user, oh, you left the kid in the car, just to give an example. So there are plenty of use cases. Why? Because the cars nowadays are equipped by so many sensors,
Yeah,
including inside the wheel. So, and every time you have a sensor, you have a TinyML, because TinyML is just another layer on top of the sensors.
perfect. Yeah, there are way too many sensors nowadays in cars. Yeah, if you can just Vinay, if you can just go for a test drive of one of the latest edition cars, uh, you will find out that there are so many sensors. Even if you leave the key behind in the car, it has a sensor which pops up. So Nicola on LinkedIn has a query which says when to select deep learning models over classical machine learning algorithms in a TinyML context.
Can I say one thing? I very like this question. I very, very like this question. Um, in the book, there is one chapter that touches the classic machine learning algorithms, in particular with scikit-learn using a decision tree. Because you're absolutely right. Here we are talking about TinyML, but TinyML is not just about deep learning. Deep learning are absolutely great for doing many things, But in some scenarios, what you just need is just a decision tree. So when to select? Well, it truly depends on the problem you're trying to solve. Well, certainly if you're working with, for instance, with images or audio, well, no doubt, probably deep learning is the way to go. When you work with sensors, you can probably try to have either deep learning or the classical machine learning models. It truly depends, because you need to take into account also the effort for the feature extraction. What it means? Well, in deep learning, usually the feature extraction is, let's say, bundled in the model. Okay, although for audio is not always the case, because in audio most of the time you have the feature extraction at the beginning. For instance, in the book, I presented the MFCC feature extraction to do both the speech recognition or the music classification. For sensors is usually one of the is widely used, the feature extraction, to have more robust models. But it depends on the complexity of the feature extraction, the complexity of the model. This is not an easy selection. But I can tell you that in some cases, you're absolutely right. Classical machine learning models can bring you the performance and also the reduction in size. That could be extremely beneficial for TinyML.
Okay. The next question we have is from Mohammed. Is there any specific repository having sample machine learning models, just to start with?
Okay.
Would our book repository be one of them?
There are some pre-trained models, not many, because the training of the model is part of the recipes presented in the book. So the book shows also how to train these models for TinyML. Why so? Because in TinyML, you don't need to lose track of the design of the model from the model deployment. Usually we think, oh, let me take a pre-trained model, let me try to run it. Well, if you use this approach, with a high probability, we won't be able to run anything on the microcontroller. Instead, you need to train, keeping in mind what target platform I want to deploy on, because the target platform influences the architecture choices in the machine learning model. That is one of the reasons. In the repository, you can find the code to train these models. So all in Colab. You just need to open Colab, Google Collaboratory, and train the model, and you have the TensorFlow Line model that you can deploy it. There is also an example to use a pre-trained scikit-learn model that you deploy on an Arduino platform.
Okay. I hope that helps answer your query, Mohammed. Before we move ahead, let's do our first raffle. We are midway through the session. I'll just share my screen so it makes things easier, and we can do our first raffle then.
Yeah.
Where is it gone? Okay. Yeah, I'll use this. And I'll just, there's a tab, it's here. Okay. So we've got about 7 entries. I'll just click on draw, and it will randomly draw the winner of the first raffle. I have no say in this whatsoever. As you can see, my hands are up here. It just auto draws. So Funso is the first winner. Congratulations, Funso.
Congratulations.
So Funso, if you can just contact me on LinkedIn. I am very easy to find on LinkedIn. My name is Tushar Gupta. You can just add +pact and you can search me on LinkedIn. Add me on LinkedIn and share your full name and email address. I will get a copy of the book shared with you. In the meantime, we will continue with the session. And there is another giveaway at the end of the session. So please continue entering the draw by adding #pact, as it says at the bottom of the tick over here. So the next question is by someone on YouTube. Can you share about the optimization paradigms used in TinyML?
Okay. So here, well, please correct me if I'm wrong. For optimization paradigms, I guess you're referring to how to optimize these models for latency and model size um, during the training, the model design and model deployment. So in TinyML, what is crucial is to keep in mind the memory and compute capabilities of the target device when you design your model. In the book, there are a couple of chapters in particular that which should help you to understand how to design model, how to set the number of parameters based on this information. For instance, there are limitations in the let's say in the hard drive this microcontroller, which is for the embedded experts. They call it flash. So we are not talking about gigabytes of data here. We're talking about probably a couple of megabytes. Therefore, these memories usually for the weights, for constant weights of the model. And when you design your model, you need to keep in mind this information because it has because if you train a large model, probably this model, I mean, and you are not careful enough, you may risk of not be able to deploy this your train model on these target devices. Everything is at that level. But there is a second step in the optimization phase, because you have trained your model to fit your target platform, but you need also the to reach very good performance on the target platform. And here you need to use your framework that exploits, for instance, libraries that accelerate machine workloads. For instance, in the context of TensorFlow Lite, if you're using an ARM CPU, you will likely use a CMC-CNN, and CMC-CNN can delegate and TensorFlow Lite can delegate these the acceleration of the critical routines to CMC-CNN to improve the performance. Is at two levels then. One is in the design of the model, crucial, because without that, your risk is not deploying the model at all. And a second is at the deployment level. So when you actually need to deploy the model on the microcontroller.
Okay. So Marcelo on LinkedIn says that I only use MicroPython with OpenMV and image. Is it possible to use MicroPython with audio, for example?
Okay, I did not use it with audio. I only use it for images. So I'm not sure there is also for audio. I use Edge Impulse for doing the audio, an audio application also in the book, and also use the CMSIS DSP library, so a manual approach to explain how to optimize the code step by step. Audio is probably the most complex. Audio models are probably the most complex to be deployed. I'm saying this because when you use an image model for classifying images or object detection or many other things, you probably only mainly focus on the model deployment. What you care is just running the model. When you talk about audio models, here you have two components: is the feature extraction and also the audio, the machine learning model. So the feature extraction, it's probably one of the biggest challenges we have right now to deploy it very efficiently. One way to do it is through CMSIS DSP, but there are no other simple frameworks that can help you to do it very efficiently. If you ask me why, the reason is the following. The reason is because for instance, when you tailor your model for a TinyML, sometimes you need to use data types which are very friendly for your microcontroller. In the context of microcontroller, for instance, floating point acceleration is not, sometimes is too much, because these devices do not have the floating point acceleration. They only use integer arithmetic. Therefore, you need to consider the feature extraction just with fixed point arithmetic or integer arithmetic. So if you use that for the feature extraction, you need to make sure that also the feature extractor for the machine learning design is the same. So in other words, the accuracy of what you deploy on the platform and what you use for training is the same, because otherwise you have a drop in accuracy. That is the second challenge, because you need to be sure that what you are going to deploy on the target platform matches exactly what you have used for training. In the context of the book, I use CMSIS DSP because, well, it provides the low-level routines in C, but also the Python routines. Therefore, I could exactly use the same implementation in Python for training and in C for deploying the model.
Perfect. Jin, I have a query while we're waiting for others to add in their queries. Uh, can you share some insights on integrating TinyML models with existing systems and workflows?
Okay, well, that is absolutely an interesting question. So, how do we deploy real TinyML applications?
Yep.
So, there are many, many ways. One of these, for sure, is to, well, you can certainly, you need, first of all, a system to that is able to upload the model over Wi-Fi or over on the air, as we commonly say. And also because these models can also be, let's say, sometimes they require to be adjusted based on extra data. So you need a system that is capable, a cloud system that is capable to upload or to change the model, the on-device model. That is usually the approach I've seen recently, because yes, it's true. Most of the time, TinyML itself does not need internet connection, but in some cases for real applications, especially in large environments, well, you need to change the model, because to a different version, you need a cloud environment. That is one. But I have also seen cases where you don't need to scale the model to many devices, but only to a few, in areas where internet connection is not an option. And in these cases, I've seen, well, models that they need to run for several months. You deploy that model, and you cannot touch it anymore. So that is the case, for instance, in a very remote region. You leave the device there, that is going to perform TinyML, is going to collect the device after a few months. Or the other case is through on-device learning. So since the model most of the time needs to be adjusted with user or environment data, there are also algorithms in the TinyML space that allows to update the model in order to improve the accuracy. In the book, there is a chapter about on-device learning, where in that case, the example is very, very simple, just to train a simple model with backpropagation. But this to give an idea that there are scenarios where you don't have internet connection, but you have the necessity to change the model or to update the model, and the only way to do it is through on-device learning. So there is a mixture of workflows. One is through the cloud environment, IoT in particular, the IoT cloud environment. The other one is one-off. So I deploy the model, I'm going to take the model, and I'm going to take the device after a few months. And the other one is through on-device learning.
Okay. Jian, what advice would you give to developers who are new to TinyML and looking to get started, other than getting a copy of the latest edition of your view book? What other advice would you give them?
Okay, so yes, there are at least a couple of advices. The first is to join the TinyML Foundation. It's a free, no-profit organization where they're organizing events worldwide. There are also meetup groups that can help you to enter this fascinating world. So if you are not part of the TinyML Foundation, I really recommend you join this, because there is also a YouTube channel where we post, where we upload all the presentations we have virtually or in person, and you can learn from the experts. The presentations are at different levels, from very beginners to to expert presentation, where they present cutting edge solutions. This is my recommendation. Of course, if there is an interest for you to have a TinyML presence in your region, so I recommend to be in contact with TinyML Foundation to see if we can connect you to other people in your region to form a TinyML group. The other thing is, there is something I very like of TinyML, and is the open source community. The open source community is so active. There are so many cool projects out there that are very relevant for TinyML. And that is one of the reasons I dedicated the book also to the open source community, because there are many resources. But of course, when you have so many resources, the most difficult part is, where do I start? And here I recommend, probably the book, because the book is the place where you find probably the some directions on how to start this study, this learning experience. So that is one of the reasons I also decided to write the book, not because I wanted just to provide a collection of recipes, but also to give directions to developers on where do I need to look at, because it wants to give exposure to the different technologies that are out there, all very relevant, that sometimes, if you're very new to this field, might be difficult to discover. That is the two advices.
Thanks, Ian. I flashed up the book for a few seconds just so the audience has context about which book you're talking about. I think we've come at the end of all the queries. I have one last query before we do our last raffle. And Jian, before we wrap up, one last query from me would be, what trends do you foresee in the field of TinyML in the coming years?
Okay. So I think TinyML has grown from a niche technology to something very stable and crucial. Now we start seeing also products with TinyML. So before it was just for very experts, so for experts and only for a few people. Now, because of the advances and the contribution from the open source community in particular, we start to see also frameworks that allows to everyone to deploy TinyML. So what I see is an enrichment of devices with TinyML capabilities. In other words, it means that probably all the microcontrollers in the near future will be powered by machine learning algorithm to give a meaning to the data. Because I foresee this. So there are all devices, we are surrounded by so many devices with sensor capabilities. But one of the problems is about the data. We cannot send infinite data to the cloud. Also because some of these data are just redundant. What we want is to give the meaning of the data to the cloud. And TinyML probably will unlock also this, to have a more efficient way to transmit information to the user. So that is what I see. So the adoption of TinyML at large scale to give a meaning, and also to reduce the memory traffic to the cloud. So sending data only when it's needed with the crucial information that we want. The other area I see probably a future change, or I hope at the same time, is on device learning, because the big effort and the big stability in this field is primarily on inference. So I train the model in the cloud, let's say, I deploy the model, that's it. But the on-device learning is getting a lot of interest because of the potential it can bring, in particular in cases where internet connection is not an option, and there are many cases. But we are not ready there because there are many different frameworks, because they need to address an important challenge, which is the memory consumption. So I expect in the near future to have a bit more stable contribution to the on-device learning to unlock new use cases for TinyML.
Perfect. Thanks a lot, Jian. So before we wrap up, we'll do a final raffle. I'll share my screen again for that. Ta-da. So our first winner of the raffle was Funso, and I've already communicated how they can reach me. And here is the second one. Let's see who it is. It's Will Update. Congratulations, Will.
Congratulations.
If you can add me up on LinkedIn if you're not connections yet, and drop me a line sharing your email address, I will get an ebook shared with you. So congratulations once again, Will and Punso, for winning an e-copy of the book each. Just get in touch with me on LinkedIn and I'll get the ebook shared with you. Jian, before we wrap up, are there any closing statements or are there any closing lines that you would like to share?
Well, my closing statement is the fact that I really hope to see even more contribution to the open source community and even more projects powered by TinyML. I think if we start thinking tiny, we can unlock very big challenges around us, because it's tiny, it's true, but with a lot of potential. Also, as I mentioned at the very beginning, for generative AI, because the algorithms involved here do not differ from what we have seen there. Also, in particular, the data type might be very, very important in that field as well.
Perfect. Thank you so much for your time, Jian, and thank you everyone who attended the session. Thank you for your queries and for hearing what Jian had to say and for getting all of them answered. Happy holidays to all of you, and hopefully I'll be back in the coming year, if not very soon now. But yeah, see you all next time. Thank you so much.
Thanks a lot for inviting. Thank you.